RF Man here. I assume by now that everyone has watched the Mr. BBI video on the Donkey Stomper amplifier. And yeah, everyone's probably aware that he made a similar video on my LDMOS board, okay, RF Man board. So I went out there to see, well, did he just single me out, or has he done this with other competitors? So it didn't take me very long to find similar videos on X-Force amplifiers, Fat Boy, Donkey Stomper, etc. And I thought I'd use the Donkey Stomper amplifier to kind of illustrate my point. There's a lot of deceptions used in that video and a lot of misinformation. Mr. BBI has a habit of providing people with a lot of misleading information, and those of us who are technical, we can pretty much see through that. But there's a lot of people out there that maybe this is a hobby, they're not as technical, and when they watch his videos, yeah, they look convincing. But let's just break it down, okay, and you can judge for yourself, okay, exactly what we're looking at, and I'll provide some explanation as we go along. So here, you can see I have the span set on my spectrum analyzer from 0 to 56 megahertz. Now, why 56 megahertz? Because that's the exact frequency span that Mr. BBI used for his Donkey Stomper video, okay? And there's a reason why. There's a reason why. So right now, I'm using my normal setup. I got my striker set to 10 meters, just slightly over 28 megahertz. I'm using my single LDMOS board, just for illustrative purposes. Okay, I'm using an RF sampler which feeds into, as you can see there, the spectrum analyzer. And then I got my Bird 43 meter, and I have my 50 ohm dummy load. So usual setup. I'm going to be transmitting at about 500 or 600 watts, which is what he used when he demoed the Donkey Stomper amplifier. So I want to stay as close as I can and replicate what he's done. So before we do that, I just want to show you what it would normally look like, okay? Just measuring it on a spectrum analyzer, okay? I'm gonna key up, okay? And you can see the center frequency there is about 28 megahertz. Let me zoom in on that, okay? And you can see my fundamental frequency. Incidentally, the attenuation is set up so that the peak of that signal is still on the scale. That's another one of Mr. BBI's tricks, is that he sets the attenuation so that the fundamental frequency, which he calls principal frequency, it's actually fundamental, it goes off the scale, so you really can't see what's going on and how many dB down a signal might be if it's off scale, right? Same, we've used oscilloscopes, things like that. It's the same effect. So it needs to be within the boundaries of the scale, of course. And what you see there is the fundamental, but I don't see any second harmonic. And the reason why Mr. BBI chose 56 megahertz was intentional, so you don't see the second harmonic. Now, if I just come over to my radio and I just lower the frequency just slightly, okay, we're going to bring it down a little bit, you can see there, okay, and now we'll go ahead and transmit. I can see the very edge of my screen, okay, left side for me, okay, there's the second harmonic, okay. And now if I change the stop frequency to 100 megahertz, sorry about that, if I change it to 100 megahertz, Okay, now the center frequency is going to be 50, so my fundamental is going to move to the left. Okay, and now I'm going to key up. Okay, and there we see the fundamental frequency, the one on the left, and then because the span is 100 megahertz, we see the second harmonic, which would be twice the frequency, right, of the first harmonic. Okay, so what's twice? We'll just call it 28 megahertz. It's 56, right? Okay, there's my second harmonic. And then my third harmonic would be about 84. In this case, slightly over, a few hundred kilohertz over. Okay, so now I can see the harmonic frequencies. Another interesting thing you'll notice is that to the left of the fundamental, right, which is 0 to 28 megahertz, there are no harmonic frequencies. Okay, and to have harmonic frequencies below the fundamental frequency, which is the lowest frequency that your amplifier would generate, really defies physical law. Okay, those of you who may be familiar with musical instruments, right? Let's take a guitar string, right? It has a fundamental frequency, that is its absolute lowest frequency, and then when it resonates, it generates harmonics, right? Now this is a mechanical device, okay, but it's the same phenomenon. So you will not have any frequencies below the fundamental, okay, and there again, there's the fundamental, first frequency on the left, and the second harmonic and the third harmonic. Okay, and you can see the second harmonic is actually about 35 dB down. Okay, very huge difference between what the harmonics are here and what Mr. BBI showed in the video he made for my amplifier. Okay, and we'll talk a little bit about that. But I really thought I would use a competitor's amplifier and a video he made on a competitor's amplifier, so I could be a little bit more unbiased. I want to be a little more unbiased there, okay? So that's what it should look like, okay? And now we're going to go and show you what he did when he measured the Donkey Stomper frequency spectrum. I'll be back. Alright, so now I'm back. I've got the same setup. I've got my striker transmitting a little over 28 megahertz. I'm using one of my single LDMOS boards. I got my RF sampler, my spectrum analyzer, and my dummy load. So it's the same exact setup. I reset the span to 56 megahertz so we can see from 0 to 56. Okay, and now I'm going to go ahead and key up my radio. Okay, and we see something very interesting there. Okay, let me just go ahead and capture this so I can explain a little better. Okay, so we see two things here that raise a lot of questions. First thing I see is, right, we're at 28 megahertz, slightly over. So here's my fundamental frequency. Okay, but I see some signals below the fundamental. Now how could that be? I just said that the lowest frequency that an amplifier will generate is the fundamental frequency, and yet I see these signals below the fundamental frequency. And what did I say earlier? That defies physical law. Okay, so the only way those frequencies can exist is if you put them there, and I'll show you in a little more detail what I'm talking about. Okay, now I don't know the exact frequencies that were used by Mr. BBI, but this is very similar, right? He has the fundamental frequency, and then he has some frequencies, some signals below and above the fundamental. All right, I try to match it as close as I could. Okay, so then he calls this in this video, the second harmonic, he calls this one the third harmonic. Well, wait a minute. We're slightly above 28 megahertz. So the second harmonic should be slightly above 56 megahertz, which means it would be off the scale. So what are these frequencies? Where do they come from? Okay, second harmonic has to be above 56 megahertz, right? Here's my frequency, okay? I'm at 28.2, rounded off. So it calls this the second harmonic, but I put a marker on there, okay? Marker number 1, and you can see it's at around 36 megahertz. So how can that be? Well, I'll show you how, okay? What I've got here is an RF generator, okay? And I know Mr. BBI has the same exact RF generator because I've seen it on his bench many times in many of his videos. And what I do is I just take two frequencies that are below the fundamental and above the fundamental frequency, and they will create harmonics of their own, okay? And that's why you see these frequencies. I got one at around 20 megahertz, so you're going to see frequencies here, and I got one at like 32 megahertz, so you'll see frequencies above the fundamental. So on both sides, okay? And I'm just mixing those frequencies with the carrier wave from my radio. That's all I'm doing, okay? So now we go ahead and look at this very closely, right? And I'm gonna go ahead and clear this screen for you, and then we'll go ahead and key up again. All right, so we'll clear this. Now I'm gonna key up. Okay, there you see the frequencies again. And I'm gonna shut off the signal generator. Okay, so what's left? Just the fundamental frequency. Okay, I'll turn the signal generator back on, and what magically appears? Some additional frequencies above and below the fundamental. So obviously this was done intentionally. It's very deliberate to mislead his viewing audience and to try to discredit some of his competitors. So I wanted people to see this. Okay, he does provide a lot of misinformation. He uses a lot of deceptionary tactics in his video, but those of us who are smart enough, we can see through it pretty much like glass. Okay, so I'm sorry, Mr. Donkey Stomper, that he misrepresented your product. He also made a video on my palette, and he misrepresented my product as well. Just a couple of comments about that, and I know some of you may have seen the video, some of you may not have, and I thought I would use a competitor's video. Like I said, he hadn't just singled me out. He's been doing this for a long time to many other competitors. So I thought I was special, but I'm not. Okay, and I got a lot of calls after that video from a lot of ham operators, and they were all very concerned that I saw all the little tricks and deceptions in his video. And I saw most of them, but they pointed out a couple that I didn't see, so I was thankful for that. But just a comment, you know, I provide a very detailed documentation package with my palette, okay, and I specify the size of the heatsink and using forced air. Never run my palette or any other palette like BBI ran my palette. You need to have a large enough heatsink. You need to use forced air through the fins of the heatsink. You need to use forced air on the top of the board to properly cool the output transformer. So again, that was all very deliberate. As far as the harmonics go, in the first half of the video, I'll call it the first half before he put my his so-called fixes in there. He didn't have my board tuned. On the second half of the video, he tunes it. Also, the harmonics on the first half of the video, he has the fundamental off the screen, so you can't see where the peak is. It's off the scale. And in the second video, he raises the noise floor so you can see the top of the signal. And then it's real interesting, if you go back and look at it, he has it set to 5 dB per division, okay, and that display is up here on my left. It's the same place on his spectrum analyzer, but then when he counts the divisions, he counts by 10. So I thought that was somewhat amusing as well. And there's a lot of other deceptions in the video, but I thought I would use another competitor just to make my point. Please, buyer beware. And yeah, thank you for your time, and I hope this was informative. It was enlightening for me. Thank you. RF Man.